Hi children, how are you? I hope all are fine. Yes children? Yes, very good. Today we are going to study about the unit 1. The title is Basic Concept of Chemistry and Chemical Calculations. So now we are see about in the basic concept of chemistry. Okay, basic concept of chemistry. So in the first title, so chemistry, the center of life. So chemistry plays a major role in providing needs of human life in our day-to-day life. So all things that we come across in life are made up of matters. Okay, children. So in the human needs things. Okay, so in the chemistry is the important role of human needs. So what is the human needs? Yes, the first one is food to eat and cloth to wear and place to live. So in this food and cloth, it produces the human, but it is the important role is chemistry. Then the next one is the fertilizer. So the fertilizers is used in the agricultural product. So in this fertilizers of the agricultural chemistry, it enhance the agricultural production. Then we built the better and strong building. They need the modern cement and concrete mixture and high quality of steel. So this is for the chemistry for construction. Okay, then the human body is made up of chemicals. So normally the presence of human stomach, presence of hydrochloric acid. So the human bodies is made up of chemistry, and then biochemical reactions. That biochemical reactions means the carbon dioxide. Okay, the oxygen is converted into carbon dioxide gas. So in our oxygen is in our breathing helpful. Okay, so in the biochemical reactions, then industries. So in the industries is life saving drugs and polymers and dyes. Then in 1980s, one of the disease is HIV. So in the HIV full form is human immunovirus. So in the HIV patients lived a few years. So study the medicinal chemistry is useful to find the effective medicines are available to fight the infections. So in the next one, in the non-eco-friendly chemical. In the non-eco-friendly chemical, it is the used in the refrigerator. So in this refrigerator is released the gas. That gas is CFC. So the CFC full form is chlorofluorocarbon. So that chlorofluorocarbon is spoil the environment. So how to decrease the gas and how to increase the green chemistry. So in this process there are many researchers working in different field of chemistry. Okay children, so in the next topic is classification of matters. Okay, classification of matters. So look around your classroom. So in this classroom is the bench, desk and windows, etc. Yes. So look around in your room. So in your room is present in chair and windows and doors and tables and pen, pencil, book, note, anything. Yes. So in this all things made up of matters. Okay, all things made up of matters. So matters is classified into two types. Okay, matters is classified into two types. One is physical classification, another one is chemical classification. So in the physical classification is there are three types. One is solid, liquid and gases. Okay, solid, liquid and gases. So what are the physical classification of matter? The physical state of matter can be converted into one state to another state. So the solid state to liquid state. So in the solid state, example is ice cube. So in this ice cube is liquid is converted into liquid state in water. So in this liquid state is converted into gaseous state is the vaporization state. So solid to liquid is the solidification and liquid to gas is the solid to liquid is the liquefaction and gas is evaporation. So in the change the temperature and pressure with a suitable state. Okay, solid state to liquid state and liquid state to gaseous state. So in the physical state of matter can be converted into one state to another state by modifying the temperature and pressure with a suitable state. Then the chemical classification. So the chemical classification is further two types. So one is mixture and another one is pure substance. The mixture is homogeneous and heterogeneous. So what is homogeneous? So the homo means same. Okay, homo means same. So in this same type of mixture is soluble. Okay, so for example water and salt and water and sugar. So water is dissolved in the salt and sugar is completely soluble. Okay, completely soluble. So in this mixture is called homogeneous mixture. Then heterogeneous mixture. So the hetero means different. Okay, hetero means different. For example, in the oil and water and sand and water. So in the water is dissolved in oil and sand, it is does not the soluble. It is does not soluble. So in this the mixture is heterogeneous mixture. Then pure substance. So in the pure substance is element and compound. Element and compound. So what is element? An element consists of, okay, an element it consists of only one type of atom. Okay, an element consists of only one type of atom. It's called element. That element example is monoatomic unit and polyatomic unit. Okay, so mono means one, poly means di, tri, tetra, penta, hexa, anything. Okay, so monoatomic unit example is gold and copper. So gold is Au and copper Cu, and polyatomic unit is hydrogen H2. H2 is the diatomic unit. Okay, H2 is the diatomic unit, and phosphorus P4. So P4 is a tetraatomic unit, and sulfur 8. So sulfur 8 is octatomic unit. So this is the element. So what is element? And element consists of only one type of atom. Okay, only one type of atom. Then compound. So what is compound? Compound are made up of molecules. Okay, compound are made up of molecules. For the best example is water. So the water chemical formula is H2O. So hydrogen is one of the atom and oxygen is one of the atom. So the compound are made up of molecules which contain two or more atom. Okay, two or more atom of different element. Okay, of different element. The water molecule, hydrogen is one of the element and oxygen is one of the element. So two or more atoms of different element. For example, in the compound is, so the first example is carbon dioxide. So in this carbon dioxide formula is CO2, and glucose. Glucose formula is C6H12O6. Okay, so hydrogen, carbon and oxygen. Okay, so three atoms. Okay, three atoms of different element. Okay, so in the next one, hydrogen sulfide, H2S. Then hydrogen and sulfur is the presence of hydrogen sulfide. Then sodium chloride. So the sodium chloride formula is NaCl in the salt. So in the sodium chloride salt is, what is the color of sodium chloride salt? White color. Okay, so sodium chloride is the solid. Okay, sodium chloride is the solid. So in this two different element, sodium and chlorine. So the sodium is a shiny metal. Okay, sodium is a shiny metal and chlorine is an irritating gas. So in this two element of sodium chloride is the different characteristics. So sodium and chlorine is the formation of sodium chloride is the crystalline solid. Okay, crystalline solid. So sodium solid and chlorine gas. The product of sodium chloride is solid. So in the next topic is atomic and molecular masses. Okay, atomic and molecular masses. So first one is the atomic mass. So what is atom? So atom is a very small particles. Okay, atom is a very small particles. So atoms are too small and to measure their mass directly. So the IUPAC name. Okay, the IUPAC name is introduce the relative scale of mass based on the standard atom of carbon 12. Okay, carbon 12. So in the C12, so 12 is the carbon atomic mass number. Okay, carbon atomic mass number. So in the carbon 12 atom is considered as a standard by the IUPAC. Okay, IUPAC is the mass is fixed the 12 AMU. Say AMU or U is the unified atomic mass unit. Okay, AMU or U is the unified atomic mass unit. So IUPAC. So what is the full form of IUPAC? So IUPAC is the full form is International Union of Pure and Applied Chemistry. Okay, International Union of Pure and Applied Chemistry. So in this one AMU is the one atomic mass unit or one unified atomic mass unit is equal to 1.6605 into 10 power minus 27 kilogram. Okay, so what is atomic mass unit? So in this atomic mass unit is defined as 1/12 of the mass of a carbon 12 atom. Okay, carbon 12 is the fixed number of 12. So the 12 is atomic mass. Okay, carbon atomic mass. Okay, so in the carbon 12 atom, in its the ground state. Okay, in its the ground state. So it is called atomic mass unit. Okay, children. Then the next one. So the first one is atomic mass unit. Then the second one is relative atomic mass. Okay, relative atomic mass. So what is relative atomic mass? So the relative atomic mass is the ratio of the average atomic mass. Okay, the ratio of the average atomic mass to the unified atomic mass unit. Okay, so relative atomic mass is defined as the ratio of the average atomic mass to the unified atomic mass unit. Okay, children. So the relative atomic mass formula is, so in the relative atomic mass is denoted in AR. Okay, the relative atomic mass is denoted in AR. Okay, then the relative atomic mass is otherwise known as standard atomic weight. Okay, the relative atomic mass is otherwise known as standard atomic weight. Then the next one is the formula. So the relative atomic mass formula. So in the relative atomic mass formula is relative atomic mass AR. So it is denoted by AR. So the formula is average mass of the atom. Okay, average mass of the atom is divided by unified atomic mass. Okay, average mass of the atom is divided by unified atomic mass. So for example is the relative atomic mass of hydrogen. So in the hydrogen AR is hydrogen. Okay, hydrogen atom. So how to calculate the relative atomic mass of hydrogen atom? So the formula is average mass of hydrogen atom. Okay, average mass of hydrogen atom in kilogram divided by 1.6605 into 10 power minus 27 kilogram. Okay, so in the average mass of hydrogen atom is the value is 1.6736. Okay, 1.6736 into 10 power minus 27 kilogram. Then in the value of unified atomic mass 1 AMU. Okay, 1 AMU value is 1.6605 into 10 to the power of minus 27 kilogram. Okay, then in this calculation, so in this 10 power minus 27 kilogram and 10 power minus 27 kilogram, is cut, then the calculation is divided by the 1.6736 and divided by 1.6605. So the answer is 1. So the AMU unified atomic mass is 1. Okay, so the hydrogen atomic mass is 1. Okay, so in the answer is 0.008, but we calculate the all the chemistry problem, the hydrogen atomic mass is 1. Okay children, so in the next one, so what is isotopes? So in the isotopes you are studying the 10th standard. Yes. So in the isotopes is same atomic number and different in mass number. Okay, same atomic number but different in mass number. Then one more another topic is average atomic mass. So the first one is atomic mass unit, then relative atomic mass, then third one is average atomic mass. So what is average atomic mass? Okay children, so in this average atomic mass is defined the average of the atomic mass of all atom. Okay, average the atomic mass of all atom in their naturally occurring isotopes. Okay, so some elements have the same atomic number but different atomic mass number, so you calculate the average atomic mass. Okay, so in this average atomic mass is defined as the average of the atomic masses of all atoms in their naturally occurring the isotopes. So isotope means same atomic number. For example, in the chlorine, chlorine is the atomic number is same 17 and 17 and different atomic mass, that atomic mass value is 37 and 37. Then the ratio, so in the chlorine 37 atomic mass, okay, 37 the atomic mass, the number of chlorine ratio is 77. Then 37 chlorine ratio is 23. Okay, 23. So we calculate the average relative atomic mass of chlorine. So 35 into 35 is the atomic mass. Okay, atomic mass. So 35 into 77. So 35 and 37. So in the ratio is 77 and 23. So 35 into 77 plus 37 into 23 divided by 100. So the answer is 35.46 U. So that U is atomic mass unit. So chlorine atomic mass is 35. Okay, so hydrogen atomic mass is 1 and chlorine atomic mass is 35. Okay, so in the first one is atomic mass unit and relative atomic mass, and next one the average atomic mass. Then the fourth one is molecular mass. Okay, the fourth one is molecular mass. So in this molecular mass is similar to the relative atomic mass, so it is called RMM. Okay, RMM. So the relative molecular mass. Okay, sometimes in the short form of in your question paper RMM. So RMM means relative molecular mass. So in this relative molecular mass is defined as the ratio of the mass of a molecular. Okay, ratio of the mass of a molecular to the unified atomic mass unit. Okay, ratio of the molecular. So for example, the H2 molecule. Okay, H2 molecule. So calculate the relative molecular mass of hydrogen molecule. So one or more atom present means molecule. Okay, so two hydrogen elements are present, so it is called molecule. So relative molecular mass is equal to, that formula is average mass of molecule. Okay, average mass of molecule divided by unified atomic mass. Okay, unified atomic mass. So in the number of hydrogen, so the number of hydrogen is 2 hydrogen. Okay, number of hydrogen is 2 hydrogen. Then into the relative atomic mass of hydrogen. So in the relative atomic mass means hydrogen atomic mass value. Okay, hydrogen atomic mass value is 1. Okay, hydrogen atomic mass value is 1. Then how many hydrogen molecules? There are 2 hydrogen. Okay, so 2 into 1. So the answer is 2U. Okay, 2U. 2 atomic mass unit. Okay, then the next one is the relative molecular mass of glucose. So in the glucose formula is C6H12O6. Okay, C6H12O6. So calculate the relative molecular mass of glucose C6H12O6. So in the carbon atomic mass is 12. Then hydrogen atomic mass is 1. Then oxygen atomic mass is 16. Okay, children. So calculate. So how many carbons are present? 6 carbon. So 6 into 12. So the 6 is the carbon number. Okay, 6 is the carbon number. So how many carbon? 6 carbon. So 6 into 12 is carbon atomic mass. Okay, then hydrogen. So how many hydrogens are present? 12 hydrogen. So 12 is the hydrogen into 1.008. So you calculate the 1. Okay, you calculate the hydrogen atomic mass is 1. Okay, then oxygen. So how many oxygens are present? 6 oxygen. So 6 into 16. So 16 is the oxygen atomic mass. Okay, oxygen atomic mass number. So you calculate 6 into 12 is 72, and 12 into 1 12, and 6 into 16 is 96. So the total value is 180. Okay, 180 atomic mass unit. Okay, atomic mass unit. So all of you see in this table number 1.1. So some elements and their relative atomic mass number. Okay, so the element is hydrogen, carbon, nitrogen, oxygen, sodium, magnesium and sulfur. So in this atomic mass number is increasing order. Okay, increasing order. So the hydrogen relative atomic mass number is 1, and carbon relative atomic mass number is 12, and nitrogen relative atomic mass number is 14, and oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine 35, potassium 39, calcium 40, chromium 51. So in this relative atomic mass number is increasing order. Okay, increasing order of the element. So all of you study the element and their relative atomic mass. So in this table column you study is the helpful to use the calculation. Helpful to use the chemical calculation of relative atomic mass and average atomic mass and then relative molecular mass calculations. Okay, children. Then next one. So in the next one is mole concept. So in this mole concept, the amount of substance are usually expressed in moles. Okay, the amount of substance are usually expressed in moles. So a mole is the amount of substance which contains as many elementary entries. Okay, many elementaries in the 12 gram or the carbon 12th of isotopes. So in this mole concept, for example, so in the number of substance, okay, in the number of substance, so you buy apples. Okay, so 12 apples means 1 dozens of apples. Then 24 apples means yes, 2 dozens of apples. So in the 12 balls and 12 apples, the number of apples and number of ball is 12. But we denote the moles form is 12. Okay, we denote the unit is dozen, 1 dozen or 2 dozen or 3 dozen. So in this chemical formula is potassium dichromate and potassium permanganate in the mole. Okay, calculate the mole concept. So in this mole concept, the total number of atoms present in the 12 gram of carbon 12th. Okay, 12 gram of carbon 12th isotopes. So in this potassium permanganate. Okay, potassium permanganate is the mole value is 158.03 gram of potassium permanganate. Then potassium dichromate is 294.18 gram of potassium permanganate. So in this 1 mole is equal to 6.023 into 10 to the power 23 entities. So this is the one important 1 mark question. So 1 mole is equal to 6.023 into 10 to the power 23 entities. So it is the mole concept. Okay. So in the next one of the table column. So calculation the number of entities in mole, 1 mole of the substance. So in the first one, name of the substance is carbon. Okay, name of the substance is carbon. Then second one, glucose. Then third one is potassium dichromate and potassium permanganate. So in the mass of the substance, is already you studied in the relative molecular mass. Okay, already you studied in the relative molecular mass. The mass of the substance is hydrogen 1 and glucose 180. Then potassium dichromate is 294.18. So in the potassium permanganate value is 158.03. So in the mass of the single atom or single molecule is the formula is the molecular mass divided by Avogadro number. Molecular mass is divided by Avogadro number. So in this Avogadro number, so what is the Avogadro number? That Avogadro number is the 6.023. Okay, 6.023 into 10 to the power 23. Okay, so the molar mass is divided by Avogadro number. So in the next column, the number of atoms or molecule. Okay, the number of atoms or molecules is equal to the second part. Okay, in the second part, the mass of the substance is divided by mass of the single atom or molecule. Okay, so in this all the compound. So in the elemental carbon and glucose and potassium dichromate and potassium permanganate. So in this all the answer is same. So the answer is 6.022 into 10 to the power 23. Okay children. So this is the calculation of number of entities in 1 mole of substance. Okay, 1 mole of substance. So today we have studied the topic is chemistry is the important role of human life, and then atomic mass, and then relative atomic mass and average atomic mass and relative molecular mass. Okay, then mole concept, and the next topic is the mole concept calculations. Okay, so now your homework. So all of you write the question. The question number 1 is what is element? And second question, what is compound? Then third question, what is relative atomic mass? And next one, molar mass. So 4 questions. So what is element and what is compound? Then what is relative atomic mass and their equations? Okay, and their equations. Then molecular mass. Okay, relative molecular mass. So what is molecular mass and then equations. Okay, so it's the formula, the relative atomic mass formula and relative molecular mass formula. Okay, then one of the table column. So in the table column, the element and their atomic mass value. So all the elements and that elements atomic mass value is you study. Okay, so if you study the element and their atomic mass numbers, it is useful to the other calculations of in the unit. Okay children, so study the all questions. Okay, study the all questions. So what is element, what is compound, and what is relative atomic mass, and what is relative molecular mass, and then the table number 1.1. Table number 1.1 is the element symbol and their atomic mass number. Okay, atomic mass number. Okay children, thank you.